Most of the 25 offsets. Hi, I'm George Crump, lead analyst with Storage Switzerland. Thank you for tuning in today. Joining me today on the whiteboard is Ritu Jyoti. She is the Vice President of Product Management for Chem and Area. How are you doing today, Ritu?
Very well, thank you, George.
So, one of the things that's driving people to our site, obviously, is anything related to solid state disk or SSDs, and of course, increasingly now is all flash arrays. And I think one of the challenges that people are struggling with, or one of the things that the concerns is, how do I make sure I get maximum performance out of that environment? And so a lot of that is architecture. So can you kind of walk us through the architectures that you see out there and what makes the most sense in your mind?
Absolutely, it would be my pleasure. So let's do a quick recap of what's happening in the industry. If you see organizations worldwide, they're experiencing rapid data growth. And if you look into the data centers of today, they have powerful servers, they have very powerful networking, they have efficient databases and apps, but they have a storage bottleneck. And storage bottleneck, you all know that it's because of the 20-year-old technology, which was actually architected for the rotating mechanical devices. And these boxes, they're so difficult to manage. They have operational complexity, they have growing footprint and power challenges. So with the invention of flash, it certainly changes the game.
Sure.
But flash, let me remind us that it's only an enabler. Okay. And why do I say that? Let's quickly walk through that. So if we look into the two types of architecture that we have in the industry, the first one is the ScaleUp architecture. And the scale-up is basically where you have the storage controllers and you have the devices. And in order for you to grow, you go ahead and add more devices to the same storage controller, right?
Right.
And you could keep on adding it, but there is a limit to it. Or you could go ahead and change the storage controller itself.
Right. Both of those become expensive.
Exactly.
Yeah.
And this is where you can see the correlation, because what happened is that when flash is introduced in this architecture, it quickly exposes the limitation that the performance bottleneck shifts from the devices to now the controllers.
Right.
The other approach is the scale-out architecture. And in the scale-out architecture, you have the storage controllers and you have the devices. In order for you to grow, you keep on adding this whole set together. So you have storage controller and devices, you have another storage controller and devices, and you keep on growing like this. So the beauty of this architecture is that when flash is such a fast media, you are growing the controller, the CPU, the networking in the same proportion with this fast media.
Right. Now what's interesting is we haven't seen a lot of flash architectures leverage scale out. Most of the scale out stuff you've seen is sort of like cheap and deep, sort of NAS, and we haven't seen a lot of that leveragement yet.
Yeah, but we are actually seeing a lot of adoption. Right. You know that we have been in the market since mid-2010.
Sure.
And this is really, the beauty is that the customers can start very small, grow with their needs. And let me quickly walk through the uniqueness as to what, Chem and Area has done from K to scale-out architecture.
Okay.
So let me do a quick and dirty picture of our, and I'll walk you through a very simple thing. So we have multiple nodes. This is like a simple, say, a logical block, say a K block that we call.
Okay.
It has, say, these are the nodes. And each one of these nodes, basically, they support two, fiber channel HBAs or two iSCSI. So each one of them have the same thing. And we actually, whatever volume is created, it's, the volumes are distributed across the entire data set.
Stripe across the nodes, right?
And we keep on adding that. So what are the key highlights? What makes us unique? If you look into the scale-out architecture, you definitely get, IOPS and bandwidth advantage because you're growing with the CPU processing power, but it comes with a latency, setback because of the extra network hop. But we have some uniqueness in our architecture to even take care of that. So first, let's take, the highlights here. In the K2 scale-out architecture, the first and the most important thing is that we actually take the entire data and the metadata, both of them. It's distributed in a very, very, sophisticated fashion, which is a patent in a new, fashion.
Right, and on a lot of the older architectures, the metadata is not distributed, correct?
Exactly. We have the entire data and metadata distributed. We are leveraging the power of the entire media.
Okay.
We have a distributed write cache, and the advantage of this is that it eliminates, the write cache it actually eliminates the hotspots.
Okay.
And then it writes the data uniformly across all the available flash.
Okay.
And also it sustains the global wear leveling.
Gotcha. Okay.
The third very important thing is that we have N-way active. And what do I mean by N-way active? In the sense that, if you have any volume that has been created in the system, any volume can be accessed by any host port on any of these nodes.
Okay.
So it can be accessed anywhere. The fourth very important thing is that I talked about, the typical scale-out architecture. They actually have the limitation of the latency because they have to do a network hop.
Right.
We actually have implemented early act. So and I'll talk about in one of the other videos as to why and what is this early act. We actually eliminate that extra network hop that happens with the scale-out
So the
architecture.
background network doesn't become the bottleneck either.
Exactly. We don't have to do an extra network hop in order for us to do the acknowledgement to the host.
Okay, got it.
And the nodes for us are connected through a proprietary internal network, which is actually optimized for performance, than using the traditional 10 gig EI SCSI.
Okay, got it.
So I think in a nutshell, this is not about just one single management. Interestingly, I've seen a lot of people, they do just single management and they say this is scale out. We are a true scale out architecture, which is up and running in a few hours in a day. And the entire data is distributed. We have a distributed write cache, and this is optimized for any kind of workload and performance.
So instead of, what we've seen in some of the scale out is they've sort of bolted flash onto a legacy architecture. And really what you did is you took scale out and essentially reinvented it specifically for flash. Is that right?
Yes. It has done a grounds up redesign, keeping in mind as to what are the characteristics of flash and how to make the best use and marriage between what is needed in the data centers and what we can do it from an architecture.
All right, and so then the bottom line for the user should be they can take this architecture and it can grow performance for them as linearly as they need it to.
Exactly.
Awesome.
Exactly.
Great. Well, thank you for joining us today.
Thank you. My pleasure.
I'm George Crump, lead analyst with Storage Switzerland. Thank you for tuning in.